So hi students, let's do one more question on this in this chapter. Okay, here the question is in the network shown below, the switch is closed at t is equal to 0. Find the currents I1 of t and I2 of t when the initial current through the inductor is 0 and the initial voltage of the capacitor is 4 volt. Okay, so here in this question the good news is that the initial current through the inductor and the initial voltage is equal to 4 volt, means the initial conditions are already given in this question. Okay, that is the one of the advantage of this question. And otherwise if the initial conditions are not given, then you have to read this statement one more time. That is, here it is written in the network shown below, the switch is closed at time t is equal to 0. If the switch is closed at t is equal to 0, which means that before t is equal to 0 the switch was open. Okay, and then you have to apply the steady state condition. Okay, but here in this question you don't have to do that because already the initial conditions are already given. That's why it's written over here, the initial current through the inductor is 0 and the initial voltage of the capacitor is 4 volt. So here the initial conditions are already given. So all you need to do is simply apply Laplace transform to this question, then find the value of I1 of s and I2 of s. Okay, and then find the inverse of I1 of s and I2 of s. That is the meaning of this question. So let's do this question. So here the transformed impedance of the circuit is given by, so let's draw the circuit. So here the switch is closed, right? So I will close the switch, and the transformed impedance or the Laplace transform of a resistor is the resistor itself, and its impedance is 1 ohm. And then the transformed impedance of an resistor is the resistor itself, 1 ohm. And what about the transformed impedance of an inductor? What is the Laplace transform of an inductor? We know that the Laplace transform of an inductor is looking like this. That is, it has an impedance of Ls and a negative voltage, and the value of the negative voltage is Li of 0. Okay, this is what we studied. So where I of 0 is the initial current through the inductor, but according to the question it is already given that the initial current through the inductor is 0, which means the value of I of 0 is 0, which means L into 0 is 0, which means the value of this voltage is 0, which means the voltage is shorted. There is no voltage source. Okay, it's shorted. So therefore we will have only this impedance over here, only this inductor over here. So therefore the Laplace transform of this inductor is simply a inductor with no positive voltage, with no negative voltage. Okay, because here the value of the voltage is 0. And Ls, what is the value of L? The value of L is 1. So 1 into S, which is S. Okay, S. This is the Laplace transform of this inductor. And what about here? This is a positive voltage, and this is the value of the positive voltage is 10 volt. Okay, so what is the Laplace transform of 10? The Laplace transform of 10 is 10 by S. Okay, the Laplace transform of 1 is 1 by S. So therefore the Laplace transform of 10 is 10 into 1 by S, which is 10 by S. Now again, what is the Laplace transform of this resistor? It's the resistor itself. And what is the Laplace transform of a capacitor? We know that the Laplace transform of a capacitor is a capacitor whose impedance is 1 by Cs and a positive voltage excuse me, a positive voltage whose value is V of 0 by S. Okay, where V of 0 is the initial voltage of the capacitor, and according here already the initial voltage of the capacitor is already given, which is 4 volt. So which means substitute the value V of 0 as 4. So which means this is nothing but a capacitor with a positive voltage. And what is the value of the capacitor? It is 1 by Cs. What is the value of C? C is 1 farad. C is equal to 1. So this is 1 by 1s, which is 1 by S. And what is the value of the positive voltage? V of 0 is equal to 4, right? So therefore it is 4 by S. So the value of the capacitor is 1 by S, and the value of the positive voltage is 4 by S. So here what you need to do is you need to find the value of I1 of t and I2 of t, right? So which means you need to find the value of I1 of s and you need to find the value of I2 of s, where I1 of s is the Laplace transform of I1 of t, and I2 of s is the Laplace transform of I2 of t. So now this is nothing. Now from here it is nothing but your basic mesh analysis equation. Okay, so all you need to do is simply apply mesh analysis and try to find the value of I1 of s and I2 of s, and then you find the inverse using partial fraction. Okay, so here let's write the equation applying KVL to mesh 1. Applying KVL to mesh 1, you get, that is, this I1 of s touches what all the elements it touches. 1 plus 1 plus s. What is 1 plus 1 plus s is 2 plus s, or s plus 2. Okay, it's touching only these three elements, right? So it is only this minus I2 of s into, and what is this? I2 is touching only these two elements, which is 1 plus s or s plus 1. Okay, is equal to, what about the voltage? Only one voltage over here, and this I1 of s is coming out of this positive terminal, right? It is going from bottom to top. It is coming out of this, so which means this positive terminal is generating I1, so it is plus 10 by s, plus 10 by s. Okay, this is the equation. Okay, I'm not going to, you know what, I'm not going to write anything else after this. I'm going to leave some space. The reason is because I want to see what will be the equation of mesh 2 is. Okay, by looking at the equation of mesh 2, and I will try to find if there's any connection between these two. If there's any connection between these two, then the circuit will become the equation will become more simple, right? Or otherwise it will be more difficult. Then you have to apply the Cramer's rule. Okay, so I will just see the equation for mesh 2, and then I will see if I can do some modification to this equation. Let's see. What is the equation for mesh 2? It is applying KVL to mesh 2. Applying KVL to mesh 2. Okay, so what do you get? Let me see. It is here, it will becomes minus I1 of s minus, for mesh 2 means I1 of s is negative and I2 is positive. So minus I1 of s into, let's see, we have here as 1 plus s or s plus 1. Okay, plus I2 of s into, and what about I2 of s? I2 of s is touching this one, this one, this one, and this one. 4 elements. That is s plus 1 plus 1 plus 1 by s. S plus 1 plus 1 plus 1 by s. Okay, is equal to, and what about the voltage? Only one voltage, that is called as 4 by s, and this I2 is flowing from top to bottom. It is flowing downwards. It is flowing into the positive terminal, which means this positive terminal is not generating current, it is opposing the current. So it is minus 4 by s. Okay, minus 4 by s. Okay, this can be written as minus I1 of s into s plus 1, okay, plus I2 of s into, and this can be written as 1 plus 1 is 2, so you have s square plus 2s plus 1 by s is equal to minus 4 by s. Okay, this is the equation. Or this s square plus 2s plus 1 is s plus 1 the whole square, right? So you can write this as minus I1 of s into s plus 1 plus I2 of s into s plus 1 the whole square by s is equal to minus 4 by s. Okay, now let's compare these two equations, see if there's any connection you can make to make this equation more simpler, to find at least one of the values. No, I'm so sorry, there's nothing you can do, which means you have to apply the Cramer's rule, right? Yeah, that's the only thing you can do. There's nothing else. So all you have to do, you have to apply the Cramer's rule, which means I need to simplify this equation much more easier, which means I need to I need to remove this s from here. So how do I remove this s? Multiply this entire equation with s, and you will get I1 of s into s plus 2 minus I2 of s into s plus 1 is equal to 10. Okay, this is the equation for mesh 1. Now the equation for mesh 2 is, I need to multiply this entire equation with s, so you will get minus I1 of s into s plus 1 plus I2 of s into s plus 1 the whole square is equal to minus 4. Okay, here you have s into s plus 1. What about over here? Here you have, here you have s into s plus 2. So sorry, no luck. So you have to apply the Cramer's rule. Okay, there's no other choice. Okay, so according to Cramer's rule, or you can say expressing the equation in matrix form. Expressing equation 1 and 2 in matrix form, we get, what will I get? Here you have s into s plus 2, s into s plus 2. Here you have minus of s into s plus 1. Here you have s into s plus 1, minus of s into s plus 1. So you have minus of s into s plus 1, and here you have s plus 1 the whole square. Here you have s plus 1 the whole square. Okay, and this is I1 of s, and here it is I2 of s. And what about the voltage? The voltage over here is 10, and here it is minus 4. So you have over here as 10 and minus 4. Okay, so this is the matrix equation, which means now you need to find the value of I1 of s and I2 of s. So first I'll find the value of I1 of s. I1 of s is equal to the determinant of the first column will be replaced by this 10 minus 4, and the other column will be the same, minus s into s plus 1 into s plus 1 the whole square by, and the denominator is s into s plus 2 into minus of s into s plus 1 minus s into s plus 1, and here s plus 1 the whole square. Okay, so this can be written as 10 into s plus 1 the whole square, and here minus of minus becomes plus, so it again becomes minus 4s into s plus 1. Okay, this is how it's written by, and what about the denominator? Here you have s into s plus 2 into s plus 1 the whole square, and here you have minus of minus becomes plus, so you have again minus s square into s plus 1 the whole square. This is the equation you're getting. Okay, here I can take s plus 1 common, right? I can take s plus 1 common over here. Here I can take s into s plus 1 the whole square as common, right? I can take s into s plus 1 the whole square as common. So see, I will get over here as taking s plus 1 common, it will become s plus 1 into 10 into s plus 1 minus 4s. Okay, minus 4s by, and here I will take s into s plus 1 the whole square as common. S into s plus 1 the whole square is common, so you'll be left over here with s plus 2. Here you left with s plus 2, and here you will be left with minus s. Okay, because s plus 1 the whole square is taken and one s is taken, so only one s will be remaining here. So you will get this one, and here I can cancel this s plus 1 and this s plus 1 the whole square, right? So it will become only one s plus 1 will remain over here. So here you will get 10s plus 10 minus 4s, 10s plus 10 minus 4s, 10s minus 4s is 6s, so you will get 6s plus 10. So this will become 6s plus 10 by s into s plus 1, s into s plus 1, and here's s and s will get cancelled, you get into 2, or this is nothing but 3s plus 5 by s into s plus 1. This is the value got, 3s plus 5 by s into s plus 1. So this is the value of I1 of s. Okay, so now, which means now you need to partially factorize this to find the value of I1 of t. So which means I'm going to first factorize this before finding the inverse. So which means this is 3s plus 5 by s into s plus 1 can be now be written as a by s plus b by s plus 1. So now I need to simply find the value of a and b. So what is the value of a? The value of a is equal to, first you look at the denominator of a. The denominator of a is s. So remove s from here, write the remaining values. It is 3s plus 5 by s plus 1. Okay, and then put the denominator is equal to 0. So here s is equal to 0. So therefore the value of s is equal to 0, which means put s is equal to 0 over here, and you will get 0 plus 5 by 0 plus 1, which is equal to 5, which means the value of a is equal to 5. Now let's find the value of b. The value of b is, look at the denominator of b. The denominator of b is s plus 1. So remove s plus 1 from here, write the remaining values. It is 3s plus 5 by s. Okay, and then you substitute the value of s is here. The denominator equal to 0. S plus 1 is equal to 0 is s is equal to minus 1. So substitute the value of s is equal to minus 1, and you will get over here minus 3 plus 5 by minus 1. What is 5 minus 3 is 2. So you will get minus 2. So the value of b is minus 2. So therefore I1 of s is equal to this one, right? I1 of s is equal to this one, which is a by s. A by s is 5 by s minus 2 by s plus 1. 5 by s minus 2 by s plus 1. So therefore I1 of t is equal to 5 into the Laplace inverse of 1 by s minus 2 into the Laplace inverse of 1 by s plus 1. Okay, so which means you get over here as, what is the Laplace inverse of 1 by s? It is u of t minus 2 into the Laplace inverse of 1 by s plus 1 is e raised to minus t. So you have 2 into minus 2 into e raised to minus t into u of t. Okay, this is the equation of I1 of t. If you want, I can write this as I can take u of t common. So you will get 5 minus 2 into e raised to minus t into u of t. Okay, this is the equation of I1 of t. Now I will find the value of I2 of t. So to find the value of I2 of t, I first find the value of I2 of s, and I2 of s is found by, the second column will be replaced by 10 minus 4. The first column will be the same, which is s into s plus 2, and here it is minus s into s plus 1, and here it will become 10n minus 4. 10n minus 4 by, and the denominator will be the same, which is this itself, s into s plus 2 minus s into s plus 1 minus s into s plus 1, and here it is s plus 1 the whole square. So now I'm going to multiply this. You will get minus 4s into s plus 2, and here you have minus of minus becomes plus. So you have plus 10s into s plus 1, okay, by, over here this is exactly the same denominator, right? So I just need to write that again, s into s plus 2, s into s plus 2 into s plus 1 the whole square, minus s square into s plus 1 the whole square, minus s square into s plus 1 the whole square. Okay, so here maybe I can take the s common, right? I can't take s plus 1 common, but I'll take s common. So if I take the s common, I'll take all of them common. Let's see what happens. So here it is nothing but, if I take s common, I will get minus 4 into s plus 2 plus 10 into s plus 1, okay, by, and here if I take, like I said, if I take this thing common, I'll write this one, I'll get this, that is I will get s into s plus 1 the whole square s into s plus 1 the whole square, and I will get here s into 2, right? Here, because it will be s plus 2 minus s, so which means I will get into 2 over here. Okay, this s and this s will cancel each other. Very good. So which means you will be left with minus 2 into s plus 2 plus 5 into s plus 1 by s plus 1 the whole square. Okay, maybe I can just I can simplify this, so therefore this will become minus 2s minus 4 plus 5s plus 5 by s plus 1 the whole square. This is equal to 5s minus 2s is 3s, and 5 minus 4 is 1 by s plus 1 the whole square. Okay, so this is I2 of s. Okay, so now I need to find the inverse of this, which means I need to partially factorize this. So 3s plus 1 by s plus 1 the whole square can be written as, so this is a repeating factor. Okay, so repeating factors means you should repeat that many number of terms. That means looking at the how many factors are there, that many terms should be there. So here it is s plus 1 the whole square, so therefore you should write the s plus 1 2 times. One is for s plus 1 and the other one is for s plus 1 the whole square. Okay, this is why if you see a repeating factor, then you should repeat it that many times in the increasing order. Okay, so therefore since there are two factors s plus 1 the whole square, so which means there are two factors, you need to write this factor 2 times in the increasing order, and then you need to find the both values of both the coefficients. Okay, now if you look over here, actually you need to simply find the LCM. So you will get 3s plus 1 is equal to a into, taking the LCM, you will get a into s plus 1 plus b, right? Because if you multiply this with s plus 1 on both the numerator and denominator, then all the denominator will be the same, so you can cancel everything. So you will get this 3s plus 1 is equal to a into s plus 1 plus b. This can also be written as as plus a plus b is equal to 3s plus 1. Okay, so it's very easy, right? So if I compare these two coefficients, what is the coefficient of s over here? It is 3. What is the coefficient of s over here? It is a. So therefore a is equal to 3. Okay, what is the coefficient of s raised to 0 over here? It is 1. And what is the coefficient of s raised to 0 over here? It is a plus b. So a plus b is equal to 1, or b is equal to 1 minus 3, which is minus 2. Or in other words, I can say that I2 of s, okay, this one, I2 of s is equal to 3 by s plus 1 minus 2 by s plus 1 the whole square. Okay, so now I need to do is simply find the Laplace inverse of this. Okay, so finding the Laplace inverse of this will be a little bit tricky. Okay, because this is actually how to find the Laplace inverse of this is, all you need to do is simply look at this. This is nothing actually. You see, we all know the equation. It is the Laplace transform of t into f of t. Okay, the Laplace transform of t into f of t is actually equal to minus of d by ds of f of s, right? Right. So in that case, if you look over here, in that case, you see, if f of s is equal to 1 by s plus 1. Okay, if f of s is equal to 1 by s plus 1, then the Laplace transform of t into f of t, right? The Laplace transform of t into f of t is nothing but minus of d by ds of 1 by s plus 1. Now what is the Laplace transform of 1 by s plus 1? The Laplace transform of 1 by s plus 1 is nothing but minus 1 by s plus 1 the whole square. You see, the Laplace transform of this is minus 1 s plus 1 the whole square, or it's nothing but 1 by s plus 1 the whole square. This is the Laplace transform of t into f of t. So in that case, I need to know what is f of t. What is f of t? F of t is the Laplace inverse of this. And what is the Laplace inverse of this? The Laplace inverse of this is e raised to minus t u of t. The Laplace inverse of this is e raised to minus t. See? So which means the Laplace transform of t into e raised to minus t. Okay, now you write u of t over here. The Laplace transform of t into e raised to minus t is actually equal to 1 by s plus 1 the whole square. Okay, so that is what we are going to apply over here. So therefore, now I can say that I2 of t, okay, I2 of t is actually equal to 3 into the Laplace inverse of 1 by s plus 1 minus 2 into the Laplace inverse of 1 by s plus 1 the whole square. Okay, and we know that the Laplace inverse of 1 by s plus 1 is e raised to minus t. So therefore it is e raised to minus t into u of t. U of t, because this is a unilateral Laplace transform. Okay, that's why I'm multiplying everything with u of t, minus 2 into, and the Laplace transform of this is, I already know it is t into e raised to minus t. So therefore it is nothing but t into e raised to minus t u of t. Okay, this is the Laplace inverse. So therefore this is the value of I2 of t, or in other words I2 of t can be written as, I think I will take e raised to minus t u of t common. Okay, let me take that as common, or I just simply write like this, that is 3 into e raised to minus t minus 2t e raised to minus t into u of t. You can write it any way you like. Okay, this is the value of I2 of t. So therefore I can now say that the answer, final answer is, therefore I1 of t is equal to, I1 of t is equal to 5 minus 2 into e raised to minus t into u of t. That's the value of I1 of t, and the value of I2 of t is equal to 3 e raised to minus t minus 2 into e raised to minus 2t e raised to minus t into u of t. Okay, so this is the answer of I2 of t. Okay, so this is your final answer.